Now that we've done a lot of work with our product rule, quotient rule, the next step is how do we use radicals within our equation skills. So we're going to spend lesson 7.6 working with how to solve equations that have radicals in them. So take a moment and copy down number 1 here, and then I'll show you how to solve this equation with the radical in it. All right, so to start with, you have the square root of 3x minus 2 equals 5. The first thing, one of the things that we need to do is we need to remove the square root symbol. So then how do we remove that square root symbol? Actually, what we do is this. I am going to square both sides of the equation. So I would be writing this. I'm going to put a parenthesis, and then I have the square root of 3x minus 2. Oh, it's a bad 3. That's a little better. Parenthesis squared equals 5 squared. Now, how do we know that this works? How do we know that this is going to take care of this? So let me go off to the side here for a second and show you something. If I have the square root, get rid of that. If I have the square root of 6 times the square root of 6, the answer to that is like 6 times 6 is 36, the square root of 36. And the square root of 36, that equals 6. In other words, notice here I have this 6, which is underneath or inside the radical sign in my original problem right here. So how does this work? How do we apply this over here with what I've written? Well, I know that this actually means the square root of 3x minus 2 times the square root of 3x minus 2. What happens with that? I'm going to follow the same pattern that I had over here. What comes out of that square root then, squared, happens to be what's underneath the radical sign. So it looks like this. I have then 3x minus 2 equals, and 5 times 5 is 25. So now I have my two-step equation. I add 2 to both sides, so I say 3x equals 27. And then divide by 3, x equals 9. So what's new for you right now is that when you have a square root inside the equation right here, I will square both sides of the equation to remove the radical sign, and now it becomes an equation that I'm used to working. Let's take a look here at problem 2. So would you pause the video for a moment and copy down problem 2. All right, problem 2. Now I have the square root of 9x minus 2 minus 2x equals 0. When we solve radical equations, I want the radical all by itself before I do any squaring. On problem 1, I just squared it right away. Notice it's the only thing over here on the left side of the equal sign is this radical. Well, in problem, my example 2 here, it's not. So I have to set that up so that I have the radical all by itself. How do I do that? Well, I'm going to add 2x to both sides. I'm going to isolate the radical. And again, I do that just by adding 2x to both sides, just like this. So now, after I do that, I say I have the square root of 9x squared, of 9x minus 2 equals 0 plus 2. These cancel. 0 plus 2x, 2x. Now I can square both sides of the equation. So then I'm going to say, all right, parentheses, the square root of 9x minus 2, parentheses, squared. So I'm squaring the left side of the equation, equals, parentheses, 2x squared, parentheses, and then squared. So I want to make sure that I square both sides of the equation. If I have variables over here, I want to put that in parentheses to remind me to distribute the exponent to both the 2 and the x. This is something you were working on that actually in the progress check for 7.3 is something in 7.2. This is something I checked on to make sure that you know the difference between when do I distribute that to both of the terms, both factors in this term, and when don't I? Well, this is the time where we distribute it to both over here on the right side of the equation. Left side of the equation, a radical squared gives me what's inside the radical, 9x minus 2. Right side of the equation, I will distribute as I've been talking about. 2 squared, 4. X to the first power squared is x squared. Do you see what's coming? And now I have an equation here. I got 9x minus 2 equals 4x squared. Guess what you're going to use? All those lovely things from chapter 5 at the end, because now I want to set everything equal to 0. And so I have 4x squared. And 9x comes over to the other side of the equal sign. And instead of positive, it's now negative 9x. And then I have a minus 2 on the left side, but when I move it over to the right, it becomes plus 2. Now I have a quadratic equation, and I'm going to factor this equation. So let's see. I have a number in front of 4x squared. So that means, let's see, are there any common factors first? Oh, no common factors. All right, build my table. Just to remind me, I want the factors of 4 times 2 is 8. That have a sum of negative 9. That kind of lends to tell me that I'm going to need a negative 8 and a negative 1. And that has a sum of negative 9. So negative 8 and negative 1. So now I got to go to my factoring skill. Let's see here. I need more space. I don't know. Space to write. There we go. That's better. Okay. So 0 equals, whoops, no parentheses yet, Mr. Ullenberg. Let's try this trick again. 4x squared. And then I'm going to put minus 8x minus 1x plus 2. And now I'm going to do my factoring by grouping, which equals common factor of the first two terms, 4x. And then I have x is the remaining factor here when I divide it. Common factor 4x here leaves a minus 2. Now I'm looking at the last two terms. Minus 1 is my common factor, and it leaves a positive x and a minus 2. So I have the same factor, x minus 2 in both terms. Wow. Now, 0 equals 4x minus 1 times x minus 2. 0 equals 4x minus 1, because now I have two factors and only one of them has to be 0 for the product to equal 0. So I say or x minus 2 equals 0. So then 4x equals 1. And divide by 4, 1/4 equals x. 4, x equals 2. And if I was to ask you to graph these, what would these two answers tell us? That's right, where the parabola crosses the x-axis. That's what we found here. And you thought you were done with factoring. Sorry, we'll keep doing that. You'll be using a lot of factoring as you go through this lesson here in 7-6. So be prepared to do that. One last thing that I want you to know and understand, when you're dealing with radical equations, if I'm ever solving an equation and I reach, this is third example, so you might want to write this down. If I'm ever solving an equation with a radical sign and I get something like this, I reach a line and it says the square root of 3x equals negative 6. The square root of 3x equals negative 6. Will I ever get that? No, right now we're always after the positive square root. So in this case, if I get to this, no solution, no solution, no solution. If I reach this, the right equation starts like that. Okay, so here's what we need to do. Let me type this on here for you. I would like for you just to, I want you on page 456. And we're going to do numbers 1 through 9. Uh-oh, why am I dinging here? There we go. 1 through 9 odd. And 23 through 27 odd. Be sure that you do the following. Show your work and check answers. I did use the odd numbers for you so you can check your answers and get feedback right away. All right, give that one a try. Turn it in when you get done. Thanks.